Alright, nice friends. The first step we may want to take here is to find a way of transporting 36 to this other side of the equation. So we find this to be what? X raised to the power of 3, okay, plus x squared, okay, minus 36 to be equal to 0. Are we there? Very good. At this point now, we break down 36 into two terms, which will be what? We have x cubed plus, okay, x squared, minus 27, are we there? Minus 9 to be equal to 0. Good. 27 is a perfect cube, and because we have a degree of 3 here, and here we have a power of 2, the reason we have chosen 27 and what? 9. Are we there? Very good. Going forward, we can rearrange to have, okay, x cubed minus what? 27, okay, plus, x squared, okay, minus what? 9 to be equal to 0. We have done no harm to the equation. We are only just what? Rewriting the expressions, right? Good. Having done this, we now have that what? S cubed minus what? 3 cubed. 3 cubed gives us 27. And we have plus x squared. Are we there? Good. Minus 3 squared to be equal to 0. And if this is correct as well, what do we observe here? We observe a difference of what? 2 cubed. And here we observe a difference of what? 2 squares. Does that make sense to us? We move on now. We know algebraically that if we have a raised to the power of 3 minus what? B raised to the power of 3. This is equal to what? A minus B. Alright, good. Multiplying a squared, okay, plus AB, alright, good, plus B squared. Are we there? And we also know that the difference of two squares, a squared minus b squared, alright, is equal to the product of their sum and their difference. So we have a plus b multiplying a minus b. Does this make sense to us? Very good. Now it is these two algebraic expressions that is what going to be used for these substitutions. We're going to be using these two algebraic expressions to form an expansion for this difference of two cubes and the difference of two squares. So we go s cubed minus what? 3 cubed would give us what? So what we mean now is this, that this whole expression can be rewritten as below. So we have s cubed minus what? 3 cubed. This will give us what? X, okay, minus what? 3 multiplying we have x squared, okay, minus 3x. Are we there? Very good. Rather plus 3x, then we have plus 3 squared, right? All right, good. Then we have here as well the difference of two squares. Are we there? Very good. And the difference of two squares is simply the product. So we have plus. Now this plus we are writing here is the plus in this particular expression, right? Very good. So we have, x plus 3, alright, multiplying x minus 3. And altogether we have equal to 0 here. Does this make sense to us? What do we observe here? We observe that we have a common term, x minus 3 and x minus 3 this way, right? Which can be factorized. Are we there? Very good. So factorizing now, x minus 3, we shall be having x minus 3 factorized. Then we have here, okay, x squared, that is this particular term here, plus what? 3x. Are we there? Good. Then plus 9. Okay. Now we have plus. Are we there now? Plus what? X plus 3. Good. This gives us equal to 0. We have made progress here, friends. Now also we can see x minus 3 multiplying. Are we there? Good. Let us collect the like terms here. Here we have x plus 3x and here we have x. So we have x squared now. Okay. And we say plus what? 4x, right? Okay. And here we have 9 and here we have 3. We have plus 12. Very good. To be equal to 0. If this is the case now, we can apply the zero product law and equate these to what? 0. So we say x minus 3 is equal to 0 and x1 here becomes equal to 3. Right? Very good. So being that we have a polynomial of degree 3, remember the original equation has a degree of what? 3, right? Very good. Therefore, we are expecting what? 3 roots. And now we've gotten only just one of the roots. To get the other 2 roots, we will use the second expression here, which is a quadratic expression because of the degree of 2, right? So we say, x squared plus, 4x, right, plus 12, all right, equal to 0 from this particular expression. Are we together, friends? Very good. Now, solving quadratically, friends, we can now use our general formula x to be equal to minus b, are we there? Plus or minus the root of what now? B squared, minus 4ac all upon what? 2a. Does this make sense to us? Good. Substituting the values a, b, and c. A is the coefficient of x squared, in this case 1. B is what? 4, and c is what? 12. Does this make sense to us? So we go, friends. We have minus b, which is what? Minus 4, good. Plus or minus the root of what now? B squared. 4 squared will give us 16, good. Minus 4ac, where a is 1 and c is 12. So 4 times 12 will give us what? 48. Does this make sense to us? Very good. Everything upon what? 2a, where a is 1. And 2 times 1 gives us 2. Are we there? Good. Now, what is 16 minus 48? 16 minus 48 will give us what? A negative value, right? And that value will be what? Minus 32. Am I correct? Very good. So we go further to say minus 4 plus or minus, the root of what? Minus 32. Are we there? Good. Everything upon what? 2. So remember this contains what? X2 and what? X3, right? Very good. So now at this point, minus 32 we can break down to become what? Minus 32 multiplying what? Minus 1. And where minus 1, are we there? Is a complex number denoted by what? Iota, right? Good. So having known this, we can say that this becomes minus 4, right? Plus or minus the root of what? 32. Are we there? Iota upon what? 2. Does this make sense to us? Very good. Now, 32 is not a perfect square, right? But we have 16 times 2, right? So we have the root of 2 multiplying the root of 16. And the root of 16 is actually 4, so we have 4 root 2 here. And that is what we are going to substitute this way. Are we there? Good. So we say minus 4 plus or minus, right? 4 root 2 iota. Good. Upon what? 2. Does this make sense to us? At this point, expecting 2 values. So we say x2 is equal to. Good. We can factorize 2 here, right? We'll be having 2, we cancel out this to give us 2 here, and 2 we cancel out 4 to give us 2 here, right? So x2 is actually what? Minus 2 plus 2 root 2 iota. Are we there? Very good. And x3, the third root becomes, all right, minus 2 root 2 iota. So you see at this point, we have 3 solutions. Remember, we had x1 to be equal to what, friends? X1 was what, friends? Good. X1 was what? 3. From here, right? Very good. Good. X1 was 3. So this is the way we solve a problem like this, right? Good. Do well to subscribe to the channel. Remember, it is your friend Sure Success. Thank you very much, friends. Like and leave a comment, please. Thanks.